Hello everyone, today we're going to be talking about systems of three variables. And so just like with the systems of two variables that we did in our previous lesson, there are three different types of solutions that we can have with systems of three linear equations. And that is one solution, no solution, or infinitely many solutions. And so since we're dealing with three variables, we see that our solutions look like our planes. And so for one solution, we see that the planes intersect at exactly 1 point. For no solution, we see that two of the planes may intersect, or they may just all be parallel together, but not all three intersect at 1 point. And then infinitely many solutions is where we see that the three planes all intersect in a line. And so a solution of this system is an ordered triple now that makes each equation true. So when I substitute that triple into any of the three equations, we come out with a true statement. So that means that our triple is going to be x, y, and z. So there's going to be 4 steps that we are going to use to solve a 3-variable system. Our first step is to use substitution or elimination to rewrite the system as a 2-variable system. So basically, we're going to use substitution or elimination to eliminate one of the variables. Step 2 is to solve the new system for both of its variables. So this is what we did in our previous lesson. And then step 3 is to substitute your answer from step 2 into one of the original equations and solve the other variable. Because step 2 is going to give you that ordered pair, so whatever your answer is for 2 of the variables. And then you're going to substitute those values of those 2 variables into one of the equations to find the value of the third variable. And then the last step is to write your answer as an ordered pair. So let's look into solving one of these. So for the first example, I have these 3 equations. 4x plus 2y plus 3z equals 12, 2x minus 3y plus 5z equals negative 7, and 6x minus y plus 4z equals negative 3. So this is a 3-variable system. I see I have 3 equations, and there are 3 variables present. There's x, there's y, and there's z. So our first step to be able to solve this system is that we want to be able to eliminate one of these variables. And so how I'm going to do it is by elimination. So you first want to see, of the 3 variables, which one would be the easiest to go ahead and eliminate. I'm going to go ahead and eliminate y first. And the reason why I'm going to eliminate y is because of this negative y on the third equation. Because of that negative y, I can easily multiply this third equation by a negative 3 to eliminate y in the second equation, or a 2 to eliminate y in the first equation. And so just so I don't get all of these mixed up, I'm going to go ahead and label my equations as 1, 2, and 3. And so my first step is I'm going to go ahead and work with equations 1 and 3. So 1, that was 4x plus 2y plus 3z equals 12. And so to eliminate y in this equation, I need to multiply this bottom by 2. So that would give me a negative 2y. So when I add negative 2y to positive 2y, I get 0. So they cancel out. So when I do that, I have 4x plus 2y plus 3z is equal to 12. When I multiply 2 in, I get 12x minus 2y plus 8z is equal to negative 6. And now when I add these together, my y's cancel out, so I'm left with 4x plus 12x, which is 16x, 3z plus 8z, which is 11z, is equal to 6. So I have my first equation that's only in two variables, only in the variables x and z. Now I need to go ahead and use two more of these to eliminate y in another case. So now I'm going to go ahead and work with equations 2 and 3. So I have 2x minus 3y plus 5z is equal to negative 7. And now to eliminate y, in this case, I can multiply the bottom equation by a negative 3. So that I end up with a positive 3y in this bottom equation. So when I multiply by negative 3, I get negative 18x plus 3y minus 12z is equal to 9. And then when I add these equations together, I see my y's cancel because negative 3y plus 3y is 0. 2x minus 18x, I get negative 16x. 5z minus 12z, I get negative 7z is equal to 2. Okay, now I have two equations that are in the variables x and z, and now I can create my new system from that. So I have these two equations, so I'm going to go ahead and write them as in their own system. So I have 16x plus 11z is equal to 6, and negative 16x minus 7z is equal to 2. And now I can use what we learned in our last lesson to solve this equation, or this system. And here I see it's already set up for elimination since my x's have opposite coefficients. So when I add these, my x's cancel. 11z minus 7z, I get 4z. And then 6 plus 2, I get 8. And divide both sides by 4, and I get that z is equal to 2. So I have what my z is equal to. Now I just need to plug z back into either of these equations to find my value of x. I'm going to go ahead and plug it into the first one. So I have 16x plus 11 times 2 is equal to 6. Subtract 22 from both sides. And then get that 16x is equal to negative 16. And then divide both sides by 16. And I get that x is equal to negative 1. So I have my z, I have my x, now I need to find my y. And so to find the value of y, I need to plug in x and z into any of the three original equations that I have here. I'm going to go ahead and plug it into that last one. So I have 6x minus y plus 4z is equal to negative 3. Now I'm going to plug in my values for x and z. So I have 6 times negative 1 minus y plus 4 times 2 is equal to negative 3. So I have negative 6 minus y plus 8 equals negative 3. Subtract 2 from both sides. And I have negative y is equal to negative 5. Divide both sides by negative 1, and I get that y is equal to 5. So I have all three values. My very last step is now I need to write my answer as an ordered pair. Remember, for the ordered pair, you need to put your x value first, your y value second, and your z value third. So I get that my answer is negative 1, 5, 2. Okay, let's look at one more example for this video. Here I have negative x plus y plus 2z equals 1, 2x plus 3y plus z equals 1, and negative 3x minus 4y plus z is equal to 4. Okay, so for this one, it really doesn't matter which variable you end up choosing. I see that for my variables x, y, and z, I have one or more equations that have just one as the coefficient in front. So I'm just going to go ahead and choose z to be the one I am going to eliminate. But you could have done either of the other ones as well. So I'm going to label my equations 1, 2, 3. And I'm going to work with equations 1 and 2 first. So here, if I'm wanting to eliminate z, I need to multiply this bottom equation by negative 2, so I can have a negative 2z. And so when I do that, I have negative x plus y plus 2z is equal to 7, and negative 4x minus 6y minus 2z is equal to negative 2. Negative x minus 4x, I get negative 5x. Y minus 6y, I get negative 5y. My z's cancel like I wanted to, and I get 5 at the end here. Okay, now I'm going to go ahead and use equations 2 and 3. And remember, since I eliminated z in that first set of equations, I'm going to eliminate z again in this case, because I want to have the same two variables for my system. So I'm going to multiply the top equation by negative 1 so that I get a negative z at the top. And so when I do that, I get negative 2x minus 3y minus z is equal to negative 1. And so my z's cancel like I wanted them to, and I get negative 5x minus 7y is equal to 3. Okay, so now that I have this, I can go ahead and create my new system. So I have two equations that are in two variables, so my new system is going to be negative 5x minus 5y is equal to 5, and negative 5x minus 7y is equal to 3. Here I see that the easiest equation or variable to go ahead and eliminate is going to be x. They both have the same number in front, but they're both the same sign. So to make them opposite signs, I'm going to go ahead and multiply this bottom equation by negative 1. And so I get negative 5x minus 5y is equal to 5. And then positive 5x plus 7y is equal to negative 3. And so my x's cancel, and I get 2y is equal to 2. Divide both sides by 2, and I get that y is equal to 1. Now I need to plug that back into either of these equations to find my value of x. I'm going to go ahead and plug it into that first equation, and so I get negative 5x minus 5 times y, which is 1, is equal to 5. So negative 5x minus 5 is equal to 5. So negative 5x is equal to 10. And then divide both sides by negative 5, and I get that x is equal to negative 2. Okay, so I have my x value, I have my y value. Now I need to plug that back in to find what my value of z is. It doesn't matter which equation you choose from 1, 2, and 3. I'm going to go ahead and go with equation 2. So I have 2x plus 3y plus z is equal to 1. So plugging in my new values, I get 2 times negative 2 plus 3 times 1 plus z is equal to 1. So -4 plus 3 plus z is equal 1. So I get that z is equal to 2. Now that I have my values of all three variables, I'm going to go ahead and write as an order triple. I need to put my x value first, my y value second, and my z value third.